In this video, I will be explaining the concept of compound interest, and I will be giving you some examples. Assume that this line represents the time. The compound interest involves an amount of money that is deposited at the beginning, that is usually called the principal. I'm going to symbolize with the letter P. And in a period of time, is earning interest. Let's call it R, the rate of interest. So the compound interest involves a nominal rate of interest. We can say an annual nominal rate of interest. This is an interest per year. And the money is earning this interest in a period of time. Let's call this time T, and it will be given in years. After this time, the money have earned this interest, and the amount is now a bigger number. This bigger number at the end is called the future value, and usually is represented with the letter S. So I'm going to represent it with the letter S, and some text would be represented with FV, future value. So the compound interest is in such a way that the money, the interest is converted, is compounded, is calculated in period of times. And after each period of conversion, the money deposited plus the interest are earning a new interest. So will be also important then the number of conversion period per years. And the number of conversion period per years will be represented with the letter M. So M will be the number of periods in 1 year. So if, for example, that usually M could be 2 or 1 or maybe 4 or 12 times per year. So if the conversion is making every month, then M equals 12. This is the formula to compute the future value. S equal the principal, so the amount of money that is deposited at the beginning, multiplied times 1 plus I to the power n. N will be the total number of periods, and this I will be the interest per period of conversion. This is the formula that sometimes you can see in textbooks. Future value is represented with FV and present value with PV. Okay, so the I, this is the interest rate per conversion. So for conversion periods, for compounding periods. So see, this I could be, if this convert every month, this I will be the interest per month. And is the total number of periods. The total number of periods in the term. The total number of periods in the whole time when the money was earning interest. This will be N. M is just, as I told you, the number of periods in 1 year. This is the frequency of conversions. So N can be computed in this way, multiplying the time times the number of periods in 1 year. So for example, if the time is 5 years, and there are 12 compound periods per year, so the total number of periods will be 5 times 12. So you multiply N, to compute N, you multiply T times M, the times the number of conversion periods. The interest, the periodic rate of interest will be computed getting the nominal annual rate that usually is given in a problem, or usually is informed by the bank, or usually is informed or needs to be informed by the person that is giving the interest, the entity that is giving you the interest. So this nominal annual rate of interest, you need to divide it by the number of periods in a year. So in this case, you get the interest in just 1 period. So I will be equal then to R divided by M. So we have these formulas, and with these formulas, we can solve problems related to compound interest. Obviously, we need to take into account that M could be, for example, monthly. So the number of the conversion could be monthly. So that means that M equal 12, or the conversion could be quarterly. That means that M equal 4, or maybe it's semi-annual, and if the conversion is semi-annually, then you need to, the number of conversion period will be 2. Obviously, it could be annually. So in this case, the number of conversion will be only 1. Okay, with this explained, then I can solve some problems related to this. Let's solve the following exercise. How much will a registered retirement saving deposit of $1,500 be worth in 15 years at 3.45% compounded quarterly? How much of the amount is interest? So how much of the final amount? So for solving these problems, we take into account the formula for computing the future value is equal P, the principal, the amount deposit that in this case is 1,500,000. We need to take into account the interest, the periodic rate of interest, I, but they tell me here the periodic rate of interest is 3.45 compounded quarterly. So this 3.45% is the nominal annual rate of interest that is always given, and we need to divide it by 4 to get this number I that appears here. And N is the total number of periods. There was 15 years, and the money was compound quarterly. So 4 times per year during 15 years means that there are 15 times 4, 60 periods per year. Let's consider all of these numbers. So for getting the solution, we have that the principal is 1,500. We also know that the periodic rate of interest will be this 3.45%. Of course, this is the same of 0.0345 divided by 4 because it's compounded quarterly. To know N, then we multiply 15 times 4, and this will be 16. We have all the numbers to compute the future value. So we have that the S will be equal to P, 1,500, times, open bracket, 1 plus I, so 1 plus 0.0345 divided by 4, 1 plus 0.0345 divided by 4, and raise it to the power n, to the power 60. So we use our calculator, 1,500, open bracket if you have a scientific calculator, 1 plus 0.0345 divided by 4, cross bracket, raise to the power 60, and then press equal. I get the answer 2,511.16, rounded to 2 decimal places. So we can say that the registered retirement saving deposit will be worth 2,511.16 in 15 years. There is another question. How much of the amount is interest? How much of the amount is interest? So how much money has earned this? I know this will be an easy question. Yes? We have at the beginning 1,500, and we have at the end 2,511 with 16 cents. So it means that we make a subtraction here and we get the interest. So always to know how much of the amount is interest, just make a subtraction. The final amount minus the initial amount, the future value minus the present value. So we have done that the amount that was interest was the future value minus the present value. So it will be this number minus 1,500, and that gives me 1,011.16. This explains this first problem. Let's see a second problem. You made a registered retirement saving deposit of $1,000 on December 1st, 2016 at a fixed rate of 3% compounded monthly. If you withdraw the accumulated amount on August 1st, 2021, how much will you receive? So again, we have a deposit at the beginning, and we want to know how much we'll have at the end. So we have a problem of finding the future value. And we have the formula here. We also have the principal. P is 1,000. That was the deposit. We know the annual rate of interest that is 3%. But because we compound monthly, I'm going to divide it by 12 to get this amount here, I. So what is maybe a little tricky to find is the time. How long was it? Was how long was the term? It was the deposit was on December 1st, 2014, and it finished on August 1st, 2021. So that was the moment of the withdrawal. Okay, so we have the solution like this. We have that the interest period is from December 1st, 2014 to August 1st, 2021. It will be nice if we compute from December 1st, 2014 to December 1st, 2020, the one that is before this August, the December 1st that is before this August. So if we have that from December 1st, 2014 to December 1st, 2020, when they have the same date, so we just subtract the number of years. 2020 minus 2014, 6 years. So from these 2 days, there are 6 years. And then get the rest of the term between this December 1st to August 1st. So count how many months from December 1st, January 1, February 2, etc., yeah, until you get August. That is the month number 8. So it will be a month. So there are 6 years a month. Always count years and months when the interest is compound interest. So you don't need to count days in this case. So it will be 6 years, 8 months. It will be 6, 8 over 12. Yes, 6 years. 8 over 12, 8 12 of the years. These are a month. So it's 6 years, 8 12. You can use this number if your calculator know how to use fractions. If your calculator is okay using fractions, okay, you can use the fractions in this mixed fractions. You can divide a divided by 12, that is 0.666666666, and then type that t is equal to 6.6666666. I'm using all the decimals in my calculator. If you decided to use decimals, try to use all the decimals in your calculator so you don't get an error of rounding at the end. So now you have t, then you have that n equal 6, 8, 12 times the number of periods. And because the number of periods is, because this is compounded monthly, so you multiply it by 12. So this number multiplied by 12 equal 80. If you use this number, because this is rounded anyway, because it has an infinite number of decimals, maybe the answer will be a little different, maybe 80.00000001. Or maybe if you don't put this 7 here, you put 6, then you're gonna have maybe 79.999999999. So I prefer to use the fractions, especially if my calculator have a key for fractions. So we have then that n equal 80, and we have everything that we need to put it into the formula. So we know that P equals 1,000, this is given. We also know that I is 3% compounded monthly, so it will be 0.03 divided by 12. With this, then I can put everything in the formula and solve the problem. So S will be equal P times 1 plus I to the power n. I make the substitution, and I have that S will be 1,000 times 1 plus 0.03 over 12 to the power 80. And now you just use your calculator. 1,000, open bracket, 1 plus 0.03 divided by 12, cross bracket, and raise it to the power 80. You press enter or you press equal, and you get 1221.10, and that gives you the solution of this second problem. Let's solve another one. This last problem says like this. An investment of 2,500 earn interest at 4.5% per year, compounded monthly. So this is the nominal rate of interest. And now, sometimes it's expressed in this way, in Latin. This is coming from Latin. For 3 years. That happened for 3 years. At that time, the interest rate is changed to 5% annually, compounded quarterly. How much will the accumulated value be 1.5 years after the change? So in this case, we have two situations. We have two interests. So the interests have changed at some moment of time. So if that happens, it will be a good idea to think before starting to solve the problems. So there was a deposit at the beginning. So there was a time. Let's represent this with a line. So that will be remind that this line represents the time. And at the beginning of the time, at the beginning of the term, there was a deposit of 2,500. So this is like an initial present value, an initial principal. So let's call it here P1, 2,500. And after, let's say here, 3 years, and with this interest, so after 3 years with an interest of 4.5, so during these 3 years, there was an interest of 4.5 and compounded monthly. So n equal 12 in this period of time. After that happened, there was a bigger amount. And this bigger amount, so the money has earned interest, and there is a bigger amount that will be the future value of this situation. So this future value will be the present value in the second period of time when there is a different interest. So it will be another period of time with the 1.5 years, 1.5 years. And in this period of times, the interest was different. The interest was 5% and it was compounded quarterly. So n equal 4. So what I'm going to do is using this amount that I have here at the end, uses as the principal of the second period. Let's call it here equal P2. And I'm going to use again the formula of the future value to compute a final amount after this 1.5 years. This will be S computing with this principal. So that will be my idea for solving these problems. So let's do it. So this principal was 25. So as a first step, I'm going to put this as a principal and I'm going to find this future value. So I'm going to use the formula of the future value. To compute I, this I will be 0.045 divided by 12. The principal will be 2,500. And the time will be 3 years. So n will be 3 times 12. Yeah? So we have that S will be 2,500 multiplied by, open bracket, 1 plus 0.045 divided by 12. And now to get n, it will be 3 years and 12 periods per year. So it will be 3 times 12 equal 36. So I'm going to type here 36. I do this in my calculator, 2,500, open bracket, 1 plus 0.045 divided by 12, cross the bracket, raised to the power 36, and I press enter. I get 2860.62, $2,860 with 62 cents. That will be the amount that we have in this point here. So that will be the future value of the first period of time that I'm showing you here with the cursor. So we have that this 2860 becomes the new principal and start earning interest at 5% compounded quarterly for the next 1.5 years. Good. So let's do that and let's put it as a principal here in the second part. So for the second step of the problem, I will be using the same formula. So obviously now here n will be different. N will be 1.5 times 4, yeah? So equals 6. So there will be in total 6 periods of time, and the interest will be 5% divided by 4, 0.05 divided by 4. So this will give me this future value. Open bracket 1 plus 0.05 divided by 4 to the power 6. Use again your calculator. 2860.62, open bracket, 1 plus 0.05 divided by 4, close the bracket in your calculator, raised to the power 6, and press enter. That gives me 3018.98. And that is this final amount in this. This is the future value. This is the accumulated value 1.5 years after the change. So let's type this. The accumulated value 1.5 years after the change of interest will be 3081.98. And with that, I finish this problem. Okay, so I think with that, I finished the explanation of what is compound interest and a type of problem that you can find, that you can get in which you need to find the future value. I hope this has been useful. Thank you.